I can take it from there for the microbes. Sound good?
Yep.
All right, sounds good.
Okay. Welcome, everybody, to the July 2020 conference call. I hope that you're all doing well. You all heard what we're going to do tonight. Jim will start with the current events and stuff he usually covers. And then we hope to have Matt Gooding on to talk about some research. And we're going to try to make that a regular or semi-regular thing on the call to try to keep you guys up to date with what's going on. And Zach Holmer will also speak. He's doing some research plots on his own land. And then I will start talking about some microbes, soil microbes, and try to teach you guys a little bit on that. So Jim, if you want to take it from here. Oh, sorry. Save questions till the end, please. So that'll *6. We'll unmute you. Push that yourself. We'll make sure we have some time at the end for questions, and we welcome them, of course. Thanks. Jim, go ahead.
Okay. Thanks, Zach. My name is Jim Hallbeisen, and I've been starting off the conference call with a little bit about current events, and probably the biggest issue here most recently has been acreage report that was released the last day of June, and it was a total surprise to everybody as the U.S. government lowered the corn acreage about 3 million acres, which turned the market around quite significantly. The market had gained a little traction as the weather was starting to dominate, but then with the lowering of the actual planted corn acres, and they did raise the soybean acres, but not to the degree that they thought they would, which leaves kind of a question mark about where are the acres at that were reported last year that supposedly aren't planted this year. And there's speculation it's gone into small grain. There's speculation that some of them just haven't gotten planted because of the price of corn with the COVID crisis that we've had and the lack of driving and the ethanol price dropping significantly, or price of gas dropping significantly. So tomorrow there will be a WASAID report on production and bushels and carry and import, exports, and they automatically know that the production for this year with that drop of 3 million acres is going to go down. Now, the carry from last year is really a big question mark at this point, and what we're hearing from the field is that the quality of last year's production with the extremely wet spring has really put a ding into that quality, so that feed is going excessively, same way with production of ethanol is being hurt by that quality. So this is going to be a big question mark. And the weather is still a big part of the market. You know, all the people that I'm talking to, there's certain areas that have been getting, decent rain, but then there's some other areas that have been living hand to mouth. Actually, here in Ohio, we've got quite a bit of dry area. We've got this pop-up stuff. Actually, the Milan plant was hit this evening with very heavy rainfall. The heat index today was, in the low 100s, 103, 104, and see that build up in a thunderstorm that basically they stream in the same area, and Milan happened to be in that area. Myself, we got rain last night on one farm, but the other two farms were totally dry. So that's basically the kind of weather that we're seeing around the Corn Belt. And again, that's playing into this price factor. Corn price was strong yesterday. Today started strong, then it backed off and weakened during the day as reports of rain popping up in different areas. For some of you guys, this wheat market has really started to take off too. Now that has somewhat to do with the U.S. production, but a lot of that is resting with the Ukraine and Europe, particularly like France. Their precipitation in the last 4 months, basically, they're saying is down quite significantly. It's less than 50% of what they normally get. So the wheat market, they're saying production will be hurt quite significantly over there. And so that the price of wheat, it went up almost 30 cents 2 days ago, and then it was up close to a dime for a while today. So you've got about a 40-cent move in 2 days, which changes that equation. It was very cheap to begin with because of the volume of it and the volume of carry. So again, we've gotten some strength out of that. So we're seeing, the amount of wheat is not increased significantly. Your spring wheat price is held pretty strong. And again, that's always a high demand product. So again, we're seeing in the commodity areas that these prices are starting to, get a little gain. Tomorrow we'll kind of determine where the resistance levels are on this, and we're hearing from guys across the country, what their next move is, and corn has basically bumped up against that resistance level, as has soybeans. $9 on beans, $3.60 to $3.70 on corn, and I know some of you guys in the East have deals going on where you're, maybe 50, 60 cents over top of that. But as you go back to the West into, the Dakotas or Western Minnesota, they're basically maybe 25, 30 cents under basis on that. So again, that's kind of the spread we're looking at, but we still gained, quite significantly compared to where we were. So the weather is going to be a big player here. They're talking another hot spell next week over the Corn Belt. Seems like the jet stream is pushed all the way to the Arctic Circle, and so this has allowed the heat to flood north, and then that's basically keeping the high pressure so that we don't have zonal flow of rain across the country. So the dry weather factor is still going to be part of that. And listening to the advisors, the money funds were basically short on corn. They didn't have the contracts bought, so they started buying because when we had this influx of heat, they don't want to be caught short with not protecting themselves. So again, all this has gone together to give us a little price momentum as far as the commodities are concerned. Another big issue that's happened, the lawsuit, the class action suit against Bayer and Roundup, and the Cancer Fund, that's basically been put on hold. Bayer has been pushing to come to a settlement on that. They both want to settle with the suits that have been filed, plus they want to put money away to protect against any future suits. And the judge that has been put in charge of that case is saying that they're going to put a stay on that settlement because Bayer is basically wanting a panel of experts to decide whether the Roundup is a cancer-causing agent. And the judge is in total disagreement with that because he feels that the settlement should be made in the courtroom. That's basically the way the settlement has been set up, and that the implementation of a panel of experts to replace the jury system with a judge, he's not going to go along with. He told them that he was inclined to deny the settlement at this point, and right away Bayer backed off and said, well, that they would have to look at his arguments and then come to a new conclusion. That's been pushed back to the end of July, basically, I think the 25th. And that's a totally different move because Bayer was ready to settle. They had already determined assets that they were going to sell in order to make the $13 billion payment. So it'll be interesting. And see, this dicamba thing is going along with that too. There were settlements in there that were part of the total settlement, plus with PCBs also that Monsanto quit making, way back in the 80s, but they were still part of that lawsuit. But the situation with dicamba now is that That's on hold. That was going to basically clear off these dicamba suits, but now that it's had a stay put on it, and the problem is right now the amount of damage that's occurring in 2020 is escalating quite significantly. You see in Iowa they had early hot weather early, and there's damage from Banville on beans and Banville on corn. There's still guys throwing Banville in there mixed on post-emerge control, and this is causing a significant amount of damage. So there's a lot of question marks about whether this dicamba, as far as soybeans are concerned, is going to be able to make it to another year. And there's a tremendous amount of questions about seed. There's a lot of dicamba beans planted. How are we going to make up that difference? How are the companies going to be able to do that if dicamba is jerked off of the market? The district court, the appellate court in California, the Ninth Circuit basically wanted to stop all utilization of dicamba, and EPA overruled them. The Ninth Circuit came back and said EPA had the right to do that, but we're talking to different farmers around the country that are saying their local suppliers, they're not, they're getting rid of what they got, and it doesn't look like they're going to bring in any more product for next year at this point. So until EPA rules that the dicamba will be utilized next year, that's going to be a case in point too of what's going to happen with that. And a lot of guys are saying that it's going to go the way of the side that you're not going to be able to get dicamba, and Roundup will be right behind that. So again, that's a lot of speculation out there. There's been speculation on the enlist beans for you guys that are raising them. They're saying that some of that speculation is fabricated, that the Bayer people are basically trying to hide behind what Dow and the other companies have done with the 2,4-D product. They've been much more conservative than what Monsanto was. So it's going to be interesting to see if they can attack that, because it was approved differently and they went about it totally differently than what Monsanto did. A couple other things I'd just like to bring up, starting in August with the sales letter. We've got an article that appeared in a publication called Biodynamics, where a PhD with a soil testing laboratory in Maine wrote an article in Biodynamics questioning the pH test and its validity in soil science. And he goes through quite an array of scientific background discussing this. And we've had a couple chemists take a look at it, and they both say they don't see a lot wrong with it. The discussion against the pH test, they're saying there's not a lot of proof there to dispel it, but the points that this gentleman makes pretty well is saying that the pH test was never designed for a non-liquid medium. It was basically designed initially for blood testing, and the developer of it said that the only other type of biological system that it would work for would probably be ocean water. So again, that's going to come out in our August sales letter for you growers, salesmen, and we'd like to see some of the customers get a look at that. The actual biodynamic article, it will be available to you, but that's not what will get sent to you. We're going to send you a shortened version of it that appeared in Acres USA. One of the key things that was in there was the discussion of the availability chart, and this gentleman is saying it really doesn't have any validity to it. And this is really where the establishment has taken a stand against the growers program by saying that the elevation of pH is going to tie up trace elements, tie up your soil so you won't have availability. And this gentleman is saying that chart has no validity to it, and that with the pH test pretty well dispels what the establishment has been using to counteract the growers program. So that, there's an article that will appear in the solution discussing that this fall. So hopefully any potential customers, you talk with your growers rep and you can take a look at that work. It's fundamentally done very well. And I think he has the background to talk about it because he's been in the soil testing business since the middle 70s. Actually, his laboratory has been designed as a biological testing laboratory, which has been totally ignored until the last several years by the establishment. And so he's got quite a head start on the regular establishment and how they approach this soil testing. And see, we're getting feedback that some of the major corporations are looking at this biological testing on soil, and they want to see some of these results on states that have been using the biological testing, that have been implementing, like the cover cropping situation, and then basically trying to control the amount of total fertilizer that's applied, because the sustainability thing is really becoming a big issue outside of agriculture. People, when they buy stuff, they want to know that it's raised sustainably, and Cargill, Walmart, these companies are taking notice of that. So it'll be very interesting to see how this soil testing biologically starts to bloom out. Now, what we're seeing, the people that are investigating it are saying it's got a lot of holes in it, just like the regular soil test. So that'll be another thing that we have to take into account. And see, the idea of the soil test being a problem, I think we're seeing that with the COVID testing. There's quite a bit of dissension there off of the medias that aren't run by mainstream. People are saying they're getting a lot of false negatives, false positives. They're actually testing things and finding things where it's impossible with what was sent to them. So the testing thing is being used as a lever, in my opinion, just like it's used in agriculture as a lever to sell fertilizer. So again, I think the validity of the soil test is going to come under scrutiny from what we've seen with the COVID testing that's been happening. Another thing that we will start to talk about for you, the growers reps in August, is several years ago we tried to implement a calculation sheet that guys could use when you sit down with a potential client when he's using a different fertility approach or methodology. And it never got any traction anywhere. A few guys took a hold of it, but not very many. And then Dick James, one of our reps in Michigan, an old mathematics teacher, he got a hold of some of that and really re-implemented it and started using it to a certain degree. And Matt Gooding picked up on it and talked a little bit about it at the annual meeting, particularly last year. And this caught Matt Schroeder's attention. And so we've tried to re-establish this calculation thing. And Matt went at it from a different approach, kind of using like a spreadsheet, which, again, I had some experience, but not very much. And once I was able to catch on to what Matt was doing, we've come full circle on this thing, and we got something to work with, we believe. Now, some of the problem is that Dick was talking about availabilities also, because when you're in discussions with a potential customer, they say, well, yeah, you can, get in there a little bit cheaper, but you're not giving us the same amount of nutrients. And see, we've always had the environmental testing laboratories saying that the availability of these fertility products are fairly poor. And so back in the 90s, the universities got certain individuals to do some testing on that. And they came out with a sheet showing these availabilities of different liquid materials, particularly with phosphorus, because they were seeing that this problem with phosphorus in these recreational waters was starting to build again. And so we've used that particular publication to give us some availabilities. And through the spreadsheet approach, we've created a sheet that you can use a calculator on, basically. And what we want to try to do is, once Matt and I have got this thing, where we can take all options with it, we're going to send out a couple examples and then probably put together like a conference call where you guys can call in, and we'll go through it and try to explain it a little bit and show you how it works. And I've tried to create all possible options. A lot of you guys compete against manure, whether it be chicken litter or turkey litter, and we've implemented a little bit of that. We've found a availability publication that dates back into the 2000s, where these guys have basically said, this is a normal analysis. This is what's available out of that. And so the price comparison's fairly straightforward. How much are you paying? $35-40 a ton for manure. And then we compare that against, less tonnage with the growers implemented or without any tonnage and the growers implemented with a nitrogen product, and compare that against manure and a nitrogen product. And we think we can do that now for you. So again, it gives you something to talk to with the prospective customer. Again, there's certain things that, the rep has to figure out. We can give you ballpark figures on some of these things. And particularly, I can dig them out in my area where I get my 28 from, but you guys are going to have to do a little searching there to find your areas and what those prices are. And again, I think some guys are just going to throw up their hands at it, but it's pretty self-explanatory. And I think with a little work with it, I think guys can catch on to it. And at the annual meeting, we plan to go into it in depth, but we'd like to see you get started on before that. So hopefully that'll go out in August, and Zach Smith is going to do some discussion on that. I've gone through the availability calculations with him so that you've got all the different types of liquid fertilizer that can be applied, whether it's cold mix, hot mix, whether it's a polyphosphate or an orthophosphate. All of those things will affect that availability, and we know where the grower stands on that. This paper pretty well substantiates that for us. So again, that discussion will come probably in that August sales letter, and then you'll be getting a packet of stuff that will show those availabilities, and then there'll be a couple sheets in there, one completed, and then we'll have blank sheets that you can make copies of with a simplistic approach where you maybe have 3 products on their current program, and then you're going to use 2 products with the growers, the growers and nitrogen, and make it pretty simple. Well, we can make it as complex as you want. They're using another pop-up material, plus they're using a little bit of dry fertilizer at the same time. You have to understand what the potential client is using, and then we can pretty well cover all options the way it looks to me from what we've got. So again, that'll be coming hopefully in August, and maybe even before that we'll have the other packet out to you. The other thing that we've been talking about at the main office is coming to the field to work with guys. This, as I said last month, that we want the sales reps to talk to customers. Actually, I've been doing a little bit of it in Ohio and went very, very nicely. Our customer was not uncomfortable at all. In fact, he was very happy to see us, and we got a real nice tour and saw some unique things. This particular customer is doing a little bit of messing around with growers placement with Matt Gooding's guidance, and we got some very interesting pictures from that, and it pretty well was substantiated again when we were digging roots on his farm. And his crops are very competitive. We don't like to say they're significantly better, but there are some cases it's very competitive and better, in my opinion. But be that as it may, we think this placement of growers, that's some of the stuff that we want to be tinkering with to try to give guys some options. Maybe we can put a little ammonium sulfate in there, but that you have to talk with your salesman. We're going to be trying to educate those guys on that to give them some different ideas. Hopefully, Matt can talk a little bit about some of the research projects he's going on. We got some pretty interesting ones. He's doing some soil testing during the growing season, which nobody else does. Everybody does their soil testing after the crop's off or before the crop goes in. So what is the soil test actually when the plant's growing? Nobody really knows that. So we're kind of interested in that. And then this placement thing, there's some different things going on with that we would like to share with guys and show them that we think it's got some real possibilities. And then just the uniqueness of the product. He's got some ideas about how to show that. Our solutions that are upcoming, a lot of those pictures from last year that you guys saw at the winter meetings will be in there with discussions on that. Again, to give you kind of a refresher course of what we had done last year. And some of those are pretty interesting. You start out going in one direction and then all of a sudden you see that we learned something totally different but very valuable. And see, this is the implementation of this, I think, has been a very good step forward for us. And the guys that kind of had the idea to try something like this, they were dead on with it. And of course, we think the right guy working on it. I always say he's ADHD, and he takes offense to it, but that's okay. But see, he comes up with those ideas that we think really can help a farmer with his own operation. Our idea is that you're not successful because of us. You're successful because you're a good farmer, and we're helping fill some of the gaps in for you. So at that point, Zach, I think I've pretty well covered everything that I need to cover, so I'm going to let you take her from there.
All right. Thanks a lot, Jim. That was great. Zach Homer, or actually Matt Gooding, are you on?
Yes.
Star 6
yep,
on me.
I'm here.
So.
Yep.
Thanks.
Yep.
All right, great. Matt, I think if you could talk about some of the research you've been doing, any updates on the soil and stuff like that too. Try to keep it to 10 or 15 minutes, if you don't mind, and then I can get in with some microbe information.
Very good. Very good. I heard Jim mention about the soil testing. What we're doing here is I think I would start with a little history of why we're doing it. One of the things that we've always talked about is the inconsistencies of soil tests, that they're guidelines at best, and how the methodologies are done are not necessarily uniform, and nor are the numbers going to be the same from any particular test, even taken within an acre. And about 5 to 7 years ago, we had a customer who one day had kind of pointed out, he goes, I'm having some issues with some dill. And he's a large vegetable grower, and he would plant dill every 2 weeks. And his third and fourth and fifth planting were all kind of clashed together, so to speak. In other words, it was all about the same height, and they needed a steady flow to be shipped off to, I think, New York at the time, to markets in New York. And so he said, hey, go look at them and see if you can tell me if spraying growers will help them. And I'm kind of looking at them and going, and so I remember digging around, and I pulled roots, and I always carry a 10x little microscope with me, and I got looking at the roots, and I could see that they were pitted. They looked like they were scored, so to speak, or scooped out, so to speak, and knew that was more than likely some sort of dissolved solid burn. the classic aspect of why a potted plant eventually needs new soil. It evaporates the water, and what's in the water is has some salts. It has calcium, magnesium, and various things, and that gets left behind and builds up to the point where the root can no longer absorb anything. And so, on a whim and not really outfitted per se, I took an old Category 3 hitch thing from a tractor that was in my case for something else I was messing with, and we went and took some soil from the top 2 inches of in around these roots from this large acreage of dill. It was looking yellow and bad, and we went back to his coffee area there in the office, and we took a coffee filter, and I took X amount of water and some of that dirt, and I leached it into a TDS meter, and was just utterly shocked at how high it was. And again, I was just guessing amounts and everything, and I knew how much we leached off with the amount of water I had run through it was just ridiculously high. And so we knew that was a dissolved solid burn. And this particular customer, and I just talked to him today here again, he's been around for 15 years. He would soil test everything about every 2 years, and they had applied multiple fertilizations of dry fertilizer over those, the life of the farm. I mean, he'd been there all his life, and they'd always put dry fertilizer based on soil tests. And so I knew something was wrong from that, and so we sent this soil in, and I asked this lady who runs this lab in Pennsylvania to leach that and tell me what those elements are that's making this TDS or saltiness in an outdoor soil on ridges. I mean, my goodness, that's just so hard to get that high that quickly. And sure enough, it came back that 2/3 of it was potassium chloride, and that's the main ingredient that's in the soil test that needs to be added supposedly for the 2 crops that they would take off of that field every year, or these fields, in crop removal. And so they've been doing this for years, and the soil tests were taken in November. And I kind of asked him, I said, well, why don't you have the people who are taking the soil tests come out and do it in July? Because that's when it was. And they won't do it. They take them in November. They run around with their little quick probe. And so consequently what happened is he immediately, I advised them to cut all their dry fertilizers in half right away, and they have to this day. And that, again, that's been several, I'm going to say maybe 7, maybe even 8 years now, they think about it, ago. And everything looks great. And so they don't really follow the soil tests, and the local agronomy people have all settled in that this, they're going to do what this guy wants ultimately, or these people want. And so I wanted to kind of look at that again and be able to do a soil test and watch and see what the numbers do. So we made up a simple grid system where every week on a Sunday night between 5 and 9 o'clock we take 2 soil samples, and they're done with augers that are, one's an 8-inch deep auger. We made up a special catching of the soil device, so to speak, and it catches the soil that the auger pulls up, and we immediately stick a probe in and take the temperatures at the 2-inch mark. And we record temperature, we bag that soil, and then we take another auger and we go down another 8 inches in that same hole and recover that soil and bag that up and take the temperature again. And we're also running data on how much rain there is the previous week, the average and low temperatures of the outside air temperature, and also the state of the crop and when it gets foliage fed. Because we want to see when we foliage feed the crop of clover. It's a hay field. It's an active hay field, first-year stand. We want to see if, the phosphate goes up from adding the 3 gallon of growers I spray on it. We're learning all sorts of things, and so we had the first month of data from it, and we got it compiled. We all had to laugh because this particular farm has been on the growers program for now 50 years. And I'm thinking there's over 30 ton of lime, somewhere very much north of 30 ton over those years of high calcium limestone. We do raise hay primarily in this farm, and the only reason we get away with it is because of all the lime Dad had hauled and I had added for my years. And one of the most surprising things is the pH of all that is both top and sub averages 6.7, which is a chuckle. Pretty much everyone would tell you it should be exaggeration, 8, so to speak. So we're seeing things on that, and it's interesting. The soil temperature is going up and down with the crop removal, and the idea also is we are leaching it. We are taking the TDS, much like I did with that vegetable grower. We're taking that TDS and seeing if the amount of dissolvable minerals, how that goes up with the temperatures, the amount of water that's there, and then we're going to, the current plan is to keep this right on going into November, because the reality of it is most soil tests are taken in November. And what I had done is I had watched the TDSs of this particular gentleman's vegetable field go from very high multiple thousands TDS down to less than 400. And so I'm thinking, all right, so, during the heat, during the crop cycle, these soil salts come up, and they're a lot different than when the soil sample's taken. And so we're going to follow this through, and we got permission to do this, and this isn't a cheap thing, but we're getting a lot of data points, and we're going to see if that falls off in November. The other thing, too, is we have to remember we're on the growers program here, so maybe it's going to be different. So I got permission from, and we've secured a location to do the same thing next year in Parsley on this vegetable farm, because it's a crop that stays there all year. And so we're going to repeat what we do here on a non-grower's farm, and in a history of high dry fertilization and conventional fertilization, and we're going to watch that, and we're going to mirror the two things. So we're running it May through November at this point. So that's one of the neat things we're doing. I just came home today, and none of the rest of the team knows this, but I just came home today with a forage test from Second Cutting Hay. This customer, I'd asked him to do this, and he did it, and very excited to see what happens. He foliage fed his Second Cutting Hay with 3 gallon of growers 12 hours before he cut it. And the test is basically where there's 3 gallon of growers on 12 hours before he cuts the hay. We're taking a sample there, and then right beside it where he didn't foliage feed with 3 gallon. And we want to see, because he has all of last year been foliage feeding 24 hours before he cuts. And he feels it's showing up in the barn, and so we're going to see if it shows up in a mineral test. Those are the type of things that just come out of the blue for us. We keep our customer base very engaged in this and got them all bought in, and so it's amazing how many things I'm hearing. Hey, I did this, I seen this, and so this is one where they actually gathered a sample. Another thing in the works too is we did some preliminary foliage feeding of soybeans, whereas Roundup is being put on in a check plot scenario. Basically what we did is we took their old rings that support rakes, the wheel rakes. When you take all the springs out, there's a 32-inch diameter steel wheel, and we took 2 of them, and we checked them out into a soybean field, and we measured the square footage of them areas and deducted down to, at 2 gallons of the acre, how much is that 5.5 square feet that's in that circle. How many drops of growers does it take to foliage feed that with an equivalent to 2 gallon of growers? And so we figured that out, and we sprayed that on there. It's 13 drops, by the way. It was kind of interesting. So basically 13 drops in 5.5 square feet basically equals 2 gallons of the acre, or very close. So then what the farmer did is he came in and he sprayed Roundup across everything. And so we have 2 data points. We have actually what a mineral analysis, we took a sample of both roots and soybeans. In other words, we did the top, and then we took the bottom, and we did the roots separate. And we want to see what the mineral analysis is before we did anything. And then he came across and sprayed the whole field with Roundup. 5 days later, we came back, and we harvested within the rings the tops of the soybeans and the bottom where the growers was sprayed. And then we also did it outside that circle again because now we have a before and after Roundup spray. And so we were able to do that. We did 2 separate samples, so it's already basically doubled up that way. since this is kind of a one-shot wonder type thing. And I think I'm getting those samples back tomorrow, and we're going to see, what Roundup does elemental-wise to a plant. Does it starve it of trace elements? Do they come back? Does growers help, keep elemental aspects within the soybeans? I don't know. I mean, we're just shooting in the dark. But again, we are allowed to do these things, and growers full support for whatever opportunities we see to learn, to be able to decipher information on best how to use this product in the whole mindset of what we do. And so those are just two of them. We probably got, I don't know, we probably got a dozen stuff going on, but some of the stuff, never gets very far, and some of it leads to something else, and we just follow the trails wherever it leads us. And so those are just some of the three examples, some long-term, short-term, and some preliminary stuff. We got to sometimes fail to figure out the protocol to get it right, where we can actually get a true understanding. So exciting times, fun times at growers, and again, so much of it works in. Both of the Zachs and Jim, are able to use a lot of the pictures and stuff generated for more educational material, and that's just awesome. And I appreciate both of the Zachs. They bring gifts to the table here and doing all this, and being able to bounce stuff off of them. Zach Smith works as the clarifier, so everybody will understand when I assemble this data, it makes it read better. Jim oversees everything, and Zach Homer's always shaking my brain and stuff and challenging different things along the way too. And he's got a bunch of plots out too that's pretty fascinating. We'll have to talk about sometime in the future. So fun stuff. So there you go. There's your 15 minutes, Zach Smith.
Actually, I'm registering 13, Matt, so thank you.
I'm done.
All right. Thanks a lot, Matt.
Yeah, yep.
All right. I'll go for about, I'll say 10 to 13 minutes, and then we'll give a chance for questions, everybody, and then we'll wrap up the call. So I've been doing a little bit of research into some soil microbes. It's a topic that is becoming increasingly talked about and important in agriculture. Obviously, by no means am I any expert. I've just done some research. I find it very interesting, and with my environmental background, I've found some connections there that have helped me to understand soil microbes better. So last in June, I think I gave about a 5-minute spiel on the microbes. I'm going to kind of pretend I didn't do that in the sense that I'll probably cover some of the same things here, and then delve a little deeper into some specific types of microbes. So in this case, it'd be bacteria. So the first thing I want to do, which I think I did a little bit last call, is just kind of set up a foundation for you guys to understand how we need to view soil microbes. I'm very much of the belief that they're not a really marketable thing that can be controlled by us to, increase yield, definitely. To fight against this disease, definitely. You just pour this jug into your planter and off you go, and you're going to get all these benefits because this type of bug does this in corn. The reason I don't think that works is that there are far too many variables in the soil. The best way to look at a soil microbe community is to compare it to any other ecosystem. So a forest, the ocean, a lake, your garden, whatever the case may be. And what I mean by that is that you need to look at it as a complex web of different relationships between different animals and plants that all support each other, whether that be in like a predator-prey relationship, a parasitic relationship, symbiosis. But they're all necessary, and they all need to be there. Otherwise, the ecosystem couldn't function properly and would end up changing drastically, which, of course, has happened in many cases. So in the soil, all these different microbes, there's far more than what I'm about to list, but you got bacteria, fungi, actinomycetes, nematodes, the larger, like the non-microscopic, the macroscopic ones like earthworms and beetles and such. All of them live in relation to each other. So same way, there's predator-prey relationships. There's symbiosis where they help each other. They'll work together sometimes. All of them have the ability to change their environment, to alter the environment around them to better suit their own species. And that's all important to take into consideration. There's two fundamental rules that I would like you guys to remember. So the first one, these populations, and when I say population, I'm referring to, like, take a shovel full of soil, you have a whole ton of different microbes in that. By population, I just mean canvassing a wide area and covering all the microbes in that area. So we might want them to be stable, as in there's no direct threat to their existence at the moment, but they're not static. They're not always the same, nor should they be. The second one is, as I mentioned before, they have complex relationships with each other, like a food web kind of. It's a complex ecological system, one that we we don't understand completely or very well at all. And therefore, we can't just manhandle our way in there and get the results that we want. So that's important. That's an important foundation to lay down, because it informs how we actually view these microbes and how we can try to get it to benefit the crops. So I'm talking now in the context of an agricultural field. Of course, they exist in soils everywhere, but in an agricultural field, we have no more control over them than we do in Sahara Desert or the boreal forest or the tropical rainforest or anywhere else. But there are things that we can do that harm and help them. So putting toxicities into the soil, that harms them. Opening the soil up for aeration, that helps them. Some tillage is okay. No tillage tends to lock the soil up. Too much tillage tends to wreck the fungal networks, the hyphae and stuff like that, which I won't get into in this call. So our practices impact them. I firmly believe that the best thing we can do is try to provide an optimal growing medium for them, optimal soil conditions, which usually just in our case means removing toxicities, and then letting them do their thing. The populations that are present in soil are different across very small areas. So if you take a step in a field, under your foot, there are populations of microbes that are going to be potentially entirely different than the next step you take. That's the reality. They're incredibly small. A lot of them can't move, so they can't colonize new areas very well unless they're taken there by something else. So they have many different populations, and that's healthy. That is, as I said before, they can alter their environment to better suit them. So if you move them, there's absolutely no guarantee they're going to survive in the new area. But if you leave them where they are and just try to help them to survive and to grow in that area, they're already suited for it. It only makes sense. Growers has talked a lot about the benefits we can get. I will go a little bit into it now. I'm just going to describe the one type of bacteria. Time is running short yet again, unfortunately, and I apologize for that. The most important and the bacteria of the most that's the most abundant in the soil, they're called decomposers. So there's between 100 million and 1 billion individuals in a gram of soil. So you can see what I mean when I say that there are tons of them beneath our feet. Bacteria, as a rule, can't really move. They're very limited in the spot they're in. Fungi can move because they can form networks, hyphae networks, that can go throughout the soil and transport nutrients. Bacteria are quite limited. They reproduce very quickly, but they're quite limited in their reach. So they are most abundant in the rhizosphere. Anybody that's been around growers has heard us talk about that. That is the area about 2 millimeters in width around all kinds of roots. And it's a very different environment there than it would be outside of that area, because the roots produce exudate, which is a sugary substance that feeds the microbes. So bacteria like easily broken down carbon structures the most. And everything, not everything, all organic materials, be that animals, plants, anything that was living at one time, is primarily made up of carbon. That's what bacteria use for energy. So they prefer the easily broken down one. So root exudate is an obvious, it's sugar, basically. It's already easily broken down. Bacteria will go after, a leaf, something like that, something that doesn't have a lot of cellulose or a lot of, I'm drawing a blank on the word now, lignin, like a woody substance would, which is why that bacteria is typically far more abundant in agricultural soils than fungi is. Fungi doesn't prefer necessarily, but it can break down more difficult to break down carbon structures like cellulose and lignin. Because using the hyphae networks, it can actually squeeze its way into small holes in the lignin, let's say, and then it releases a metabolite that breaks down that material, and it can access the energy there. So bacteria can't do that. They can't form these networks, and they're not mobile, so they much prefer the easily broken down carbon structures, which is why they're the most abundant in the rhizosphere. Decomposers, although they do provide a sort of natural manure in the sense that they break down materials, and then when they die, that becomes available to the plant. We talked about that before at growers. The most important thing that they do is just keeping nutrient cycles going. So an important part of any nutrient cycle is that when something dies, it has to be broken down. Those nutrients have to be returned into the cycle. If it didn't break down, the earth would look vastly different than it does right now, because everything would just be laying there that ever lay there. Those nutrients, those elements would all be tied up in that tissue, unable to go anywhere else. Bacteria, because they're so numerous and they're everywhere, are the primary decomposers of stuff like that. So they keep that engine going in the soil. They keep that nutrient cycle going in the soil, and that could be any nutrient cycle. I think that's where I'll stop for today. Next month, guys, we'll try to spend more time on this stuff. I know it's of interest to some of you. I'll try to get through bacteria and fungi next time. And I apologize we didn't get as much time today, but I think that Jim and Matt's portions were very important as well. So I'll give a chance for questions now for any of us. It's *6 to unmute yourself. We'll just give a minute for that. All right, no questions. In that case, the August conference call is going to be on August 13th at 10 p.m. Eastern Time again. We hope to hear from you guys there, and thanks for listening in on this one. Have a happy summer. Good night.